So we had an example where we're talking about average velocity versus instantaneous velocity, and there are a lot of different types of rates of change. So in general, we have an average rate of change of y with respect to x would be given change in y over change in x. That's what we practiced in chapter 1. So we had a rate of change of population with respect to time. Velocity, average velocity is a rate of change of distance with respect to time. And so we want to get used to the idea that something that we are a little bit more familiar with, velocity, is a rate of change of something with respect to something else, because in other contexts we're going to be looking at other different types of rates of change. And then we want to talk about instantaneous rate of change. So similar to what we did with instantaneous velocity, we want to look at instantaneous rate of change. We don't want to look at the average rate of change of population between 2010 and 2015. We want to know what is the rate of change at 2015. And so we have an instantaneous rate of change. And in this case, I'm going to change it a little bit. I'm the instantaneous rate of change of f of x, which were our y's, instantaneous at a. So for instance, we are looking at the instantaneous velocity at 7 seconds. And so we don't have a pair of things, we're just looking at that moment in time at that production level. And so for this is defined as, similar to what we did with velocity, we let the change in x, our time intervals for velocity, get shorter and shorter. So we can look at the limit as x goes to a of f of x minus f of a all over x minus a. That's how we calculated the difference between the distance we traveled at x seconds minus 7 seconds all over the time elapsed, which were the difference between those two time intervals. Another way of looking at the same thing is if you let h being the difference between x and a, you're looking at a plus h minus f of a all over h. And these fractions here they have a special name called the difference quotient. They are a quotient of differences. And what you're doing is you're looking at these values of these difference quotients as either h goes to 0 or as x goes to a. And what happens is this was so important to look at in lots of different contexts, they needed to call it something. And that is called the derivative. So we have the derivative of f of x at a is denoted by f prime of a. And notice how I verbalized that. It's verbalized f prime of a. It's kind of like an apostrophe, but it's a little straighter than that. So every time you see this, especially in calculus, you just verbalize in your head or to each other f prime of a. And is defined by f prime of a is the limit as x gets closer and closer to a of f of x minus f of a all over x minus a. Or, equivalently, the limit as h goes to 0, f of a plus h minus f of a all over h. You might see this in the book a little more often, but I actually prefer this because we're a little bit more familiar with this in other contexts, which we'll talk about a little bit later.